So, hello guys, welcome to the P1 program. This lecture is called P108.6. So, this is going to be a problem session, right? We are going to do a single problem. No, so I'm going to what I'm planned is that I'm going to handle some more problems, and we're going to do some of these problems where Newton's laws are applied, and we are going to solve them and find out ourselves how to generate a notion for solving problems. So that's the basic intention with this session here. So this rest of these videos will be problems. So the first aspect is that I'm going to introduce the problem. Okay, so basically the problem is like this. So we have a surface, right? So this is a surface, and there is a box on the surface, right? This is the box. Okay, let this be the box. And what I'm going to do is that I'm going to push this box with a velocity, with a force, and this box will move with a velocity. And what happens afterwards is that this box is going to fall off this side, right? This side, and it's going to step down some distance. Say these are steps. Okay, so these are steps, and I'm going to step down like this. Okay, so it's going to fall off, and it's going to reach this point, right? The box is going to reach this point and then fall off like this and reach the end of this point, this step. So the box is going to fall from this height, and it's going to fall onto this point. Okay, so basically what other information that we have is that the box is going to travel some distance, say s distance. Okay, and it has an initial velocity v0, right? And the frictional coefficient is mu k, kinetic friction of the surface. And let's say each of these steps have some height h. So h and h, so the total height, right, total height will be what 3h, right? So the total height will be 3h, and each of these steps have a distance which is each step has an x distance which is d, right? So the total distance downside, right, so this distance will be 3d. Okay, and the total distance of the whole of the base, right, this whole distance, right, will be 3d plus s, right? So plus s, so that will be the total distance. So this is the problem, right? So I can find out various things. Let's find out what the distance s is, right? So my question here is, what is s, right? So what will be s, right? We need to find that out. Now how can you find that? That's the question. Okay, so basically what I'm going to do is that I'm going to split this problem into two spheres, right? The first sphere is this motion, this linear motion here, right? When the box is moving from this direction to this direction with some velocity, so initial velocity v0, and when it reaches this final point with the influence of the frictional force from the surface, this box will have some velocity, say final velocity vx, right, after reaching this point. And then it falls off, right? Falls off just like that. So it's a free fall, and it reaches this point, right? So these are the two stages, and the first stage is, say, from reaches from the v0 to vx. So let's call that time 1, t1, and the second will be t2, right? The final free fall from the higher surface to the downside position, right? So that point, that free fall, let's call it t2. So the first time interval t1 and second time interval t2. So that's the whole problem, and splitting into. Now what happens in t1, right? What happens in t1? So that's the I have to find out s here. Okay, so s is the point of concern here. So in t1 what happens is, you see, the box is here. So I'm going to redraw it, the box and the frictional surface with the mu k friction, right? And the box will reach here with some velocity vx and v0 here, right? In the meantime, what happens is that, so you can see there is no y direction, motion in y direction. So you can say ay is equal to 0, right? Straightforward. Ay is equal to 0, and ax will be some velocity we don't know, some acceleration we don't know. Now let's write in terms of Newton, right? So Newton's third law, write down that. So F is equal to ma, that's the basic thing, right? We can write down. So Fx in the x-axis will be some ax, right? And Fy will be some may, right? So ax is equal to 0, sorry, ay is equal to 0 because there is no acceleration in the y direction, but ax is still there. So Fy will be equal to 0. Okay, okay. So let's, in the first equation, Fx equal to max, let's write down the forces are. Okay, now we need to look at the forces. So if you look here, you can find out that the first force you can see is the frictional force, right? So frictional force is there. So if this body is moving in this direction, friction will be in the opposite direction. So frictional force, Fr, we have defined it. Frictional force is some mu constant, which is frictional coefficient times the normal force, right? So what is the normal force here? So normal force, when you have a gravitational force like this mg, the normal force will be in the opposite direction, right? So that will be equal to n mg, right? So n and mg, normal and frictional force. Now if you look at that case, you can see that the total forces here, right, ma must be equal to, let's take whatever that is going to the left as positive, okay, and whatever that is going to the right as negative. I'm using that convention. Whatever goes down as negative, and whatever goes up as positive. Okay, so this is our sign convention for this problem. Okay, so I hope that's clear. Now if you look at this problem, the normal force is in the up direction, so that is in the positive direction, and the mg is in the down direction, so that is in the negative direction. So in the y-axis, you can see may, right? May, which is the force. The normal force is in the positive direction, and the other force is in the gravitational force in the downwards direction. So n is minus mg. Ay is equal to 0. There is no motion, acceleration in the y-axis, so this is equal to 0. So n is equal to mg. We found out that. Now if you look back, so fx in the x-axis, what happens in the x-axis? So in the x-axis, max, right? So in the max axis, you can see the forces here is the frictional force and the motion, right? So only acting is frictional force, and frictional force is in the left direction. So left direction we have taken right direction. The frictional force is in the right direction, so right direction we have taken as negative, so you can call it negative. So max is equal to minus frictional force, which is equal to some mu k times normal force, right? Normal force with a minus sign. So normal force is just mg, so this is equal to some mu k times mg with a minus sign, right? So that's what frictional force, that is equal to max, right? So now you can say m and m cancels, and so you can say ax must be equal to some mu k with a minus sign times g. So ax is equal to mu k times g. Okay, we found out that. Okay, now what I can do is that, let's write down the equations of motion here. Now we are in this problem here, first stage. So the equations of motion, basic equations of motion, says that some v is equal to v final vx is equal to some v0 times v0 plus ax, or at, and also the distance s will be some s0 plus v0 t plus half what at square, right? So ax t square in the case. So this is t1, right? So all these are for t1. Now what I can do is that, I can rearrange the equation, this equation, and let's find out t1. So t1 will be equal to vx minus v0 by ax, right? Okay, that will be t1, right? So that's easy as it is. So we have found out t1. Now substitute that back into this equation of distance, right? So distance s will be, s0 will be in the origin, so it will be 0. So v0 times t1 is equal to vx minus v0 by ax plus half ax, right? So half ax times v minus v0, vx minus v0 by ax the whole square, right? Now there comes some cancellations. So s is equal to what, some v minus what, v minus v0, v0 times vx. Okay, I'm going to cancel some things. So v0 times vx minus v0 by ax plus ax and ax cancel, so you get half what, vx minus v0 the whole square by ax, right? So now what I can do is that I can take the vx minus v0 outside. So vx minus v0, let's take vx minus v0 by ax outside. Okay, so that will be much more easier, right? So you get v0 here in the rest plus what, half half of vx minus half of v0, right? So that's what you get. Okay, I think I did it right. Now what I can do is that you can write s must be equal to vx minus v0 by ax. v0 and half a v0 will cancel out, so you get this will cancel out and can not cancel, you get a half. So you get half of vx minus v0, right? Okay, that's what you get. Now this vx minus v0 times vx minus v0 here will get you a minus b, uh, so a minus b times, okay, this had, okay, this was not half, right? V minus v0 will be like v minus half v0 will be v0, right? Half v0, v0 by 2, so it's a plus sign, sorry about that. So vx minus v0 times vx plus v0, a minus b times a plus b, that is just a square minus b square, so that is vx square minus v0 square by 2 of ax, right? So that's the distance, right? So we are supposed to find out the distance s, right? So the s is our question here, right? Our question is s, and we have found out an equation for s. Now we only know, what we know is that we know the distance d, which is the length, right? So we know the distance d and the height h, and we know the v0, we know the mu k. So that's all we know. Now our equation here has some complicated vx, right? Vx, we don't know vx, we don't know what 2ax is, right? We don't know the acceleration. Now there comes some, we need some simplification, right? So we need to find ax and bx square, right? So how can you do that? How can you find out the unknown, right? So I'm going to do this here. Let's, so for that we can use the second time scale, which is t2, right? T2 scale is when the object falls from this height, uh, right, from this height to some steps, right? 3 steps actually. So 3 steps and it's going to fall over here, right? So this is the second case. So each had each height h and each distance d. So we had a total height of 3h and total distance of 3d, right? Okay, so that's the case here. Now what I can do is that, so x distance is equal to 3d and y distance is equal to minus 3h. Why minus 3h? Because our sign convention says whatever goes down is negative. So y distance is measured downwards from this point, so it's minus sign. The magnitude is 3h, but the sign is minus 3h. You have to follow the sign convention always. Now what I can do is that I can write down the what equation of motion again. So x is equal to some x0 plus v0 t plus half at square, right? So half at square. So in the x direction, right? In the x direction, you can see in the x-axis there is no acceleration, right? There is no acceleration because the only force acting here is the gravitational force. So the gravity is the only thing acting downwards. So the acceleration due to gravity is the only acceleration which is in the y-axis, and the x-axis acceleration is 0. Okay, there is no acceleration, right? It started with the velocity, it is going to free fall. Now, so with that in mind, what we can do now is that what we can do now is that we can write for the x case, right? So x start from x0, which is the initial starting point, no, it doesn't matter, times some v0 x v0, the velocity where this start, right? It started from rest here with v0 and it moved and gained some velocity vx, right? So vx is the initial velocity here in the x direction, right? In the x direction, so it's just vx times t2 here. We are looking at the second time interval, and in the y-axis we have some initial point x v y0 is just 0, and then there is no initial velocity, it starts from rest, right? The velocity at this point in the y-axis is 0, and it is starting to free fall, right? So you can say the velocity is 0, so you get half minus half gt square, right? Because it is in the downwards direction, so it's a minus sign, right? So we found that as well. Now what we can do is that we can find t2 here, right? We can find t2 here. So t2 is just, so t2 will be equal to x by some vx, right? So x by vx is t2. Now if you know the x distance, which is what, x distance is 3d, so you can substitute that, you get 3d by vx, right? And the y distance, right? What we can do is that I can substitute for t2 in the this equation. Okay, so you get y must be equal to minus half times g times t square, which is t2 square, which is 3d by vx the whole square. Okay, simple as that. Now I can simplify. The y distance is what? Y distance is minus 3h. Substitute that back in, right? So you get minus 3h must be equal to minus half g times 3d by vx the whole square. So you cancel out things, right? You can cancel out things right here, and you get what, v 3 and 3, 1 3 cancel out for 3, so you get h is equal to what, half g by 2 or g by 2, right? 3 3 9 3d square, 3d square, right? 3d square, and there was something of 3d square, okay, 3d square by vx square. So vx square will be equal to what, 3g, okay, I'm going to rewrite it here. So vx square must be equal to 3 g d square by 2h. Okay, so that's very simple. So that's the equation for velocity vx. We found out vx, right? Now let's substitute that back into this equation where vx was there, right? So we found out vx. Now what our equation where we got troubled was, we don't know ax, right? So we found out ax, right? Ax was what? So we found out ax is equal to what, 2m mu kg, right? So we found out ax is equal to mu kg, right? Where is ax? I found out ax here. Okay, so ax is equal to mu kg, right? I don't remember where I found out that. Anyways, let's do that. So ax will be equal to mu kg. So here is ax is equal to mu kg, right? So this is ax. Sorry, I forgot where I put it. So anyways, so ax is, we found out ax, so ax must be equal to some mu k minus mu kg, I guess. So it's equal to minus mu kg, okay, minus mu kg. And vx, right, vx, we have found out vx, right? So the value of vx square, right, vx square is equal to 3g d square by 2h, right? So vx square is equal to 3g what d square by 2h. Okay, so we have found that as well. Now let's substitute that back into this equation. All that remains is substitution. So s is equal to vx square, which is 3g d square by 2h, minus v0 square divided by 2ax. So it's 2 times minus mu kg, right? So this minus sign, okay, this minus sign is, I'm going to, this was something left behind. Okay, so this minus sign will be what? Minus can sign can be taken up and you get v0 square. So you get v0 square is equal to v0 square minus 3gd square by 2h, sorry, by 2h divided by, okay, divided by 2 mu kg, which is equal to s, right? So we have found out the equation for s, distance in terms of what? Distance in terms of what? Mu k d h and what? v0, right? So this was very simple. So our task was to find out the problem, solve this problem and find out an equation for this distance, our distance, based on in terms of v0, mu k, uh, h and d, right? And we did that. So it's very simple as that. So I hope you guys got this idea. So this is how you can apply Newton's law and get out something that is very much beneficial. We just used the Newton's law, second law, and we solved a very complicated looking problem but very easy problem. Okay, so I hope you guys benefited from this lecture and this problem session, and for more videos you keep watching and subscribe please. Okay.